Compressor motor windings. Any single-phase induction motor is not self-starting. It requires additional torque to rotate the rotor. To provide additional torque, starting winding is necessary. Single-phase compressor has two motor windings, the start winding and the run winding. These two windings are wired together in series inside the compressor motor stator. Three wires are attached to these windings, one at each end and one at the common junction of the two windings. The pins are called the start, run and common pins terminal. The key fact you need to know is that the starting winding always has a higher resistance than the running winding. Check and identification of compressor windings. Check the continuity between terminal pins of compressor motor. After checking the resistance between these terminal pins, we found running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Summarily, we found that resistance between CNR running windings equal to 20 ohm, resistance between CNS starting winding equal to 40 ohm. Have we found resistance between SNR? Hold both windings remain in circuit equal to 60 ohms. By this exercise, we can search out the running starting terminals. Check short circuit of compressor motor or any other motor. Select one terminal of a motor and touch it with lead of ohm meter or continuity meter. Touch another lead of ohm meter, continuity meter with metal casing of the compressor or appliance you are checking. Check the continuity is there, compressor motor is grounded. If there is no continuity, compressor motor is not grounded.
Starting relay is most important. The relay coil is connected in series with the running winding and connect points are connectors in series circuit with starting winding.
The relay allows the current to flow through the starting winding of the motor until the motor reaches about 2/3 of its rated speed. At this stage, the current flowing through relay coil gets normal, magnetic intensity goes down, not able to hold the weight of the plunger gets down due to its weight, then disconnects or opens the contact point, results into open the starting winding circuit. To operate properly, the relays must be right size for the motor. Be sure it has the same electrical specifications as the original. Relay is an electrically operated switch used to disconnect the starting winding or starting capacitor from the circuit when the motor reaches at its rated speed. Types of relays. Current magnetic relay. Current relays are usually found on low torque, small horsepower motor. Current relay are sometimes called amperage relay, since it is the ampere draw on the circuit that operates the relay. Solid state relay. The solid state relay does not actually use a switch to take out the start winding. When the compressor is idle, the relay is cool and its resistance is very low. When the voltage is applied, the start and run windings are energized simultaneously and the compressor starts within a few seconds. The start winding current that is passing through the relay causes the relay to set quite hot. Potential type relay. Potential type starting relay is wired with a capacitor. Overload protector. An overload protector is connected in series of electric motor in any condition. When the motor draws more current than the normal, the OLP stops the motor operation. It consists of a bimetal disc and a resistor through which the current passes carried by the compressor. When too much current is being drawn, the resistor heats the bimetal and opens the contents. It will reset in 1 or 2 minutes and will try to start the compressor again. Check the continuity between the terminals of the thermostat. It should be in an on position at a constant range of temperature. Take the bowl with ice and salt mixture, -15 degrees Celsius. Insert the sensing bulb into the ice properly. Take the temperature of ice. After a few seconds, the thermostat gets cut off. The ohm meter does not show any continuity in between the terminal of thermostat. Now, by turning the knob of thermostat, we check it at different temperature settings. In the same way, we can check the condition of door switch and light bulb with the help of continuity meter. With the help of ohm meter, continuity meter, thermostat on-off position can be checked. The electrical part in frost-free refrigerator: cooling coil fan motor, timer switch, cooling coil defrost heater, cabinet coil heater, drip tray heater, cooling coil fan motor, cooling coil fan motor. It is shaded pole motor, 220 volts. The motor circulates the temperature evenly in the freezer cabin. The motor is connected with the door switch when the cabin door is opened. The switch opens the contents and disconnects the motor when the door is closed. The contacts start the supply motor, rotate the fan and circulate the cool air. The fan motor is installed in front of cooling coil, tubes and fins type that is installed in between the walls of refrigerators. Timer switch. It is placed in a small PVC housing. A small motor is attached with teeth wheel. It is used to defrost ice in the freezer by controlling the operation of heater coil. On certain time interval, heater coil is installed with freezer coil. Timer switch work on clock mechanism when cooling coil gets over frost by time of 12 hours. The timer switch cut off the compressor supply and passes the supply to heater coil for a set time, say 15 minutes. Again, the timer switches off the heater and compressor gets start. Wiring circuits of refrigerators and deep freezers.
Okay students, so let us revise what we have learned till now.
These are the common basic tools for this purpose. Swagging is a means of shaping copper tubing so that operation is accomplished with a punch type of screw type swedging tool. Swedging permits two pieces of soft copper tubing of the same diameter to be joined together without the use of fittings. Flaring. When connecting tubing to fittings, it is a common practice to flare the end of the tube. Pinch-off tool is used whenever it is necessary to seal off copper's tubing. We can make good leak-proof joint as it is showing. The refrigeration cycle works in 4 phases: compression, condensation, expansion, evaporation. The conventional refrigerator consists of the components like compressor, condenser, capillary tube, expansion device, evaporator, filter. The frost-free refrigerator consists of compressor, condenser, filter, capillary tube, expansion device, evaporator, evaporator motor, defrosting heater, temperature control, and timer. Refrigeration capacity. Removal or absorption of 12,000 BTUs per hour or 3024 kilocalorie per hour is equal to 1 ton of refrigeration. Compressor motor windings. Single-phase compressor has 2 motor windings: the start winding and the run winding. The relay allows the current to flow through the starting winding of the motor until the motor reaches about 2/3 of its rated speed. At this stage, the current flowing through relay coil gets normal. Magnetic intensity goes down, not able to hold the weight of the plunger. Plunger gets down due to its weight, then disconnects or opens the contact point, results into open the starting winding circuit.